time to continue with the next session, which is going to address the traffic management plans in combination with the CIS approach in exchange. CIS is for collaborating ITS services. And Fabrizio, the floor is yours.
This is my presentation. It's about the collaborating ITS services, which are complementary to the data delivery, information delivery business case on the exchange specification. So exchange interaction among centers is not controlled in the information delivery function. The processing of the delivered information and the outcomes of those processing is the key input to the supplier node to further action. Coordination among centers to set up a network consistent traffic management is key. So collaborative ITS services is the tool to take up shared and coordinated decision to set up simple device setting action or complex structured traffic management plan as a countermeasure to improve road network level of service among different road and traffic operator competencies.
The CIS TM plan requirement design is set. That is being based on experience about impact on road condition and frequency of sequencing occurring. The traffic engineer part that we see also in the rerouting may design solution to cope with problems with which arise in the road operation. We have been based our modeling also on the outcomes of the previous program projects. For instance, from EasyWay TMS deployment guideline through the EUAP revision and the further ITS handbook from EUAP, we have the traffic management plan, which are described by some concepts that we used as input in our modeling. Strategy, scenario, measure, actions will be defined and described in a more precise model in using the DATEX 2 methodology. Let's see an example of a traffic management plan. Traffic management plan is when a situation occurs, we need to cope with this situation, managing the road accordingly. We set up the scenarios, which is an accident that may occur and disrupt traffic with heavy impact. And we have organization involved in this management. After, we define a set of action, which are strategy, measure, and action, which may be undertaken to cope with the situation. And these are well described in a paper which describe what each of the actor and the involved organization should do in these cases, and specific information management and VMS setting for the management of the situation should be done. This is a published traffic management plan design schema for the north of Italy that I found in the web. So this is a shared information designed and signed by road operators, policy, and the police. Sorry. So let's see how this works in real life. After we have decided this schema to manage, if there is a situation on the road, you can understand that you need a measure to cope with. This is done sharing among the involved center, which manage the different stretches of road, the need and the possible solution. That might be a solution which is found now, or should be a predefined, designed solution. So after the sharing, and this is achieved and approved among the centers, you put in place the rerouting. and you monitor the situation evolution. Of course, the accident will end, the road will be free. You should update the measure because there is more operation to be done. At the end, anything will stop. So this is a life cycle. There is a triggering condition for executing a traffic management plan. There is a management and a shaking, and there is a resolution, a life cycle for traffic management plan operation. We use the acronym TM plan, as TMP could be managed for something different, temporary, but TEM plan is our acronym for traffic management plan. Let's see how this is modeled. We have a business scenario. We have a problem definition phase. The problem, which is the scenario of which may occur on the road, the organization, the resource which may be used by each organization. This is considered in a feasibility study, which design a CIS or TM plan design. So after the feasibility study, the discussion, and it is defined. And after the agreement, a CIS activation contract is stipulated with all the implementation details, all the reference among the center to fully implement the measure on the road. Then this is the design phase. The static information has been decided how to cope with the information. This is the papers. After we go real time. The accident occurred. There is an identification of the need. There is a service request to be shared among the center, and there is a feedback on the service request to be managed on the handshaking. So operation phase is a workflow management based on service request and service feedback. We will see more later. This is modeled by info data-based scenario, strategy, measure, and action. So let's go how this data had been modeled in the specification on TS 16 part 8, sorry, 161578. The operation is part of the CIS exchange specification, and this will be followed later. Let's see before the specific DATEX 2 content specification for traffic management. This is the model which provides two publications, TM plan table and TM plan operation mostly. These are the two packages which are included in the model. Let's see the definition. Scenario is the overall situation. A response is any combination of strategies, measure, and action. A response, possible response is done of strategy. Strategy is the idea, the overall idea, not the specific measure, not the specific action, because a strategy may be achieved with different measure. We can have a strategy and then different measure to cope with. So measure are the set of action which will be managed in order to activate a specific strategy as a response to a specific scenario. And then we will have an action, which is the single operator action, which is taken by a single operator, which compose the measure. This is done in the modeling. TM plan table management is the predefined set of the scenarios and the possible response to manage the scenarios. So this is a static part which is exchanged after the design phase. It is a prerequisite to manage the TM plan operation. If you with this table exchange, you achieve the possibility to reference the specific designed TM plan with a reference instead of specifying it in real time. So this is very useful to define the agreement occurred among the actors. This is mostly used to define the identifiable, so the reference that will be passed in the DATEX 2 publication after for operation. This could be exchanged also offline because it's not needed to be exchanged in real-time exchange. How a response is modeled. A response we see is maybe achieved by a strategy or maybe achieved by a single measure. A strategy is when there is a option to implement a strategy with multiple measures. Each measure then has its actions to be instantiated. Let's see how each strategy and measure are used in this model. A strategy may be just defined with an identifiable to be used after in the operation phase, or a strategy may be reused within the publication for the same for different scenarios. And so the response could also be a strategy by reference if already defined in another previous shared scenario. The same is for measure. Measure is a definition or can be reused by a previous measure that can be used for a scenario or another scenario, for accident or management of road work with heavy impact, for instance. Then action definition. Action here, again, it can be a reference from a previously defined action or an action definition itself, which at this point, the action should instantiate an operation action template to specify how this action is implemented, meaning which action is this. This is optional because in general terms, you can only have the ID reference because it is all done, the exchange is done offline for all the other details. But this helps and allows to express specifically the operator action to the template. The template of the operator action allows to manage any information like as a situation record delivery, just only with the information needed at static, not in real time. So we have the location where the operator action should be instantiated and the type of the operator action that refer to the situation publication type of the operator action there, road or carriageway or lane management type, for instance. So this allows to define what at the real time as a situation record should be instantiated to manage that scenario as a response. Rerouting management enhanced that has been shown by Jörg previously can be added as well. So TM plan operation, here is the real-time handshaking. The real-time operation may refer to a predefined TM plan. So the TM plan table has been exchanged before, and the reference or the specific measure or strategy or predefined action, either that could be instantiated, can be shared through this publication. But these are optional, as we can also only define the need of an operation and then allow the specification to specify this in another way. But the publication allows to deliver all the detailed information. The other, when you don't have a predefined TM plan configured, you need to go to the non-predefined TM plan operation. So it's a new situation that you want to manage with an exit closed, but you hadn't a traffic management plan designed. Then you can specify in the needed actions directly by the operation template in a on-the-fly non-predefined TM plan operation setting request. So predefined for all designed, well-designed and already exchanged designed plans by a table, non-predefined for whatever other need doesn't have the support of a designed traffic management plan. Then we have also some extension to add to the operator action the reference to the traffic management plan operating. So these are a situation publication extension that allow the information of the traffic management plan to be delivered in the situation publication. And also we can have as an operator action a signed setting, meaning the setting of a specific VMS which enable to deliver the VMS setting for specific management of an accident or a forecast, for instance. So how do I deal? How can I exchange a TM-PAN publication? How? For information delivery, it's just the TM-PAN, the DATEX 2 standard way of usage. We do the for TM-PAN definition, TM-PAN activation status, we do information delivery. So we make aware our center to which we exchange of the operating status of the traffic management plan. But to allow and enable the decision flow, we need collaborative ITS service, which enable the service request and service feedback pattern to define a common workflow to implement the TM plan management, take decision, and monitor the implementation of the traffic management plan, so the yellow line. CIS exchange specification as are part of the exchange. We recall this figure from the previous presentation on exchange. We have further requirements than information delivery. The exchange is bi-directional. We have a request and a feedback in the other sense. It may be transactional, preemptive or non-preemptive, but this is we don't deal with preemptive transaction, so atomic transaction. We do support to processing. Yes, we need to support the information processing in the workflows normally. So operator need to manage devices. For instance, simple devices can be used as well, not only for the traffic management plan, but the simplest case is I set a VMS with a specific message. This can be done as a non-predefined traffic management plan. I need to set up a VMS message for special, not forecast usage. So I can switch camera, I can manage a lane control system, traffic light. These are possibilities that can be achieved by the CIS use cases. Information delivery actor. Now we go to defining the framework. We had a supplier and a client for information delivery. The supplier gives the information to the client. The client pulls the information from the supplier, or the supplier pushes the information to the client. In our model, we have a different area. We have ITS system. We are the traffic control center, traffic information center, which have available services. And the ATS services are, as stated here, camera, VMS setting, activated traffic management plan, but also information delivery service, broadcast, or activated as a VMS setting is a broadcast of in a specific area of a specific message, or CITS we added. These are services offered by the systems, and there is a system who requests a service, which can provide a service, but also can offer request a service. So a CIS, it's a service requester demanding a service to some service provider to form a combined service from the different system, which is a collaborative ITS services. It is a distributed services operation, coordination and monitoring and working and setting. So we have a service requester, we have many service providers, we can do the service request. This may be done in two phases. So before we ask for agreement on setting the plan and then to execute. When there is a possibility to have this two phase, because you need confirmation. But you also can just ask for the implementation, the center. For instance, if I need only a simple VMS setting, and I don't bother if this will be done or not to manage other information on my site, I can have an implementation request, and that's it. I don't know the agreement. If it will be refused, I will manage in another way. So while normally when we do the agreement, is because if only we all agree, they can proceed and execute the traffic management plan. And then we have the answer, the service feedback, that is yes, no, could not, can go, or timeout, no answer. After that, this implementation is done. So this simple pattern, service request and service feedback, is what is standardized under the CIS specification. We have seen before in the exchange how the exchange is modeled. We don't have now a supplier, but we have a service requester and service provider system, which have an exchange agent, a service requester agent, and service provider, and the interface, which is a service provider, which allow the service request and service feedback. This is the specialization for simple CIS. Simple CIS is a sessionless exchange. It doesn't care about the establishing a session. It may be used then for extemporary on not predefined traffic management plan action with no agreement, for instance. So if I don't need the agreement, I just need a service now, I raise the put CIS service request to the provider, and I will manage the answer. The two interfaces offer a method. The provider offers put CIS service request. The requester need to offer the put CIS service feedback as a method to receive the feedback. So the stateful CIS add the management of a session, open session, close a session, keep alive. This is to be done when you need to establish a session and to monitor precisely the session and the status of the network. As if any of the node broke connection, you are not anymore able to know the status of that node to go on monitoring the activation of the status of the agreement. So it's very important to monitor the session and the network status in that cases. So in that case, we need a stateful CIS, which may be more complex, of course. How these service requests and service requests? Okay, the CIS add also further information to be exchanged. We have seen today the message container with the payload publication and the exchange information which support the feature of exchange. We then add the CIS information that both model the service request and the service feedback information, meaning the reference to a specific traffic management plan implementation that has been delivered in order that I want to deliver what. And we have the service that we may instantiate are, for instance, broadcast delivery, easy, TMP activation, VMS message processing, the setting of a specific message for the as a simplified case of the management. TMP activation, then the action that is was one of the information of the service action in requested action is in the service request. The action I can ask for agreement, for implementation, and then for cancellation, termination, processing, status information. These are the predefined action which may be delivered as in a request. And the definition of the outcome of the feedback will be, no, the action is not compliant or compliant. Yes, the first check. Or yes, it has been success or failed. Or it's under processing, it has been rejected, it has been timed out. So these are the possible answer and feedback of the service request. So here we have all the ingredients to manage the workflow among a service requester and a service provider. We have an application level request, a service request application level. Beware, we only define in our specification whatever is among the service requester and service provider as an handshaking. We don't define application level logics, which is dependent on the application. But the overall management should be like that. Service request need arise. There is a service request which is sent via put sys service request, and the provider makes all the processing needed to understand the request and to manage the answer and deliver the first return exchange information. Okay, the first check is only syntactical, semantic, if I have received a well-formatted message, and that's resolved the service request has been delivered. So this is the exchange specification domain. The service feedback, now the processing has been done on the service provider system. So we can prepare a service feedback if the service has been, the action requested has been undertaken or not. It's success or fail. And so this logic is application level logic. We don't care in the specification. And when we have finished with the information, we can deliver the put service feedback to the service requester, from the service provider to the service requester. There could be some syntactical check and the exchange of the correct receive of the feedback is sent back. And this is the sys service feedback specification. Other things occur on application level, which are useful to understand and to manage the overall workflow, but the specification of exchange deal only with the put service feedback, put service feedback, put service request, and their return information. So how these should be combined with the traffic management plan model? The service request and the service provider, the service request is compound of a traffic management plan payload, for instance, with the traffic management plan operation information, and the CIS information part of the message container, which refer to the service activation and the action, and the requested action agreement or implementation. And then there is an exchange return to only complete the information has been received in the CIS service request has been received, the exchange information feedback, the first return information. After there is a service feedback, which is managed by the service provider to the service requester. And this is compound, again, of information, mostly CIS information, exchange information, of course, and the exchange return. This CIS information refers to the content that has been delivered in the previous message. So this is how it works, should work in real life. There is an accident, there is a road blocked, and we need to put this as an information. The information delivery is the first thing that has been done. After the center decide they need a rerouting. The rerouting is, first of all, defined among the involved center. It's an agreement, proposal agreement. After this, it's, if all agree, it could be implemented. And then an implementation request again go to the centers. When all is implemented, and if all have agreed, you can already deliver the measure to the traffic information center, yes. And then you receive the implementation, the activation from the different center from the traffic management plan. And this concluded the implementation phase of the traffic management. So now it's implemented, and again, the traffic management plan status is implemented. So these agreements are managed by CIS. This is data delivery, information delivery for the operation TM plan status of the publication, traffic management plan operation. So CIS operating and life cycle. Any activation phase starts, activated, updated, and terminated. So when there is a first activation, it starts an agreement, then it will be an implementation request, then there is an evolution, whatever, and at the end, it will be terminated. All of these transition is driven by a CIS exchange of two-phase or one-phase SIS request and SIS service feedback with their activation request and feedback, success, fail. And this mixed with a traffic management plan operation, which has a traffic TM plan operation status, agreement requested, agreement rejected, implementation requested, implemented, activated, termination requested, terminated, just to show a few. We see how the combination of the CIS exchange and the evolution of the traffic management plan will evolve. So, starting with a new operation, TM plan operation activation. It's agreement requested. The TM plan is in agreement requested, and the CIS for the service feedback to agree is instantiated. The answer is success. So after the received success, we go into the TM plan implementation requested. If this is correct, of course, success, it will be implemented. This is not error, no problem management, all fluent management. After the implementation, we will have possible update of the TM plan with a new agreement requested and new processing of the agreement workflow. Or we can have a termination requested, which lead to the terminated status or success. But this success is the SIS feedback response. We can have also the fail. If this is fail, if the agreement requested, I have an option to manage, could be agreement rejected or update the TM plan and ask for a new agreement. Or if it fails the implementation because something happens on the real-time environment and it's failed, it cannot be activated, you can either decide to abort the implementation or to go to the agreement request for a new updated TM plan. But also you can have fail. I cannot manage anymore. I need to cancel the request. And so you go to the final state. There are other options, of course, of fail. Of course, it's not a termination requested failed is to be understood. So fail remain like a termination request, but has to be managed by other exchange, information exchange and other management. Could be also here. And after the cancellation request, also we have the cancellation, which could be the cancellation of TM plan, which has been activated once, is cancelled, but it has been activated, or activation cancelled. So no TM plan has been managed in the operating environment anymore because the activation had been cancelled. So this is the overall. Of course, this implementation logic depend on the application level implementation and negotiation. So we give the basic breaks to build such an environment, but we need to tailor this. What we specify in the exchange specification are these, the handshaking among the service provider and service requester exchange. So, for implementing a traffic management plan workflow, we need to exchange TM plan table, properly defined TM plan. We trigger the TM plan operator activation with a predefined TM plan reference or describing the non-predefined operation within the activation publication. And then we have the CIS exchange with the agreement and implementation request. Agreement is optional. And then manage the life cycle of the CIS. To manage the error, you need application level logic. You need knowledge-based engine or operator manual decision. So this is to be well described in other level of specification. We don't deal now with DATEX and with the exchange specification. It's application bottom-up level. Maybe one of the topics for the next study in the European environment. We have some documentation of this. We have, of course, the DATEX2 directory. We had a CIS demonstrator, which has been developed based on the previous version 2.3, which allowed for CIS and TM plan to be managed via a DATEX2 extension. And there is a demonstrator, demonstrator on the website with enable the information. You will be able to go through the information that I described in this exchange presentation, and also the other elements with some further detail and sample of implementation. So we have also some XML file and so on for the content. Okay, so traffic management workflow negotiation is enabled by the TM plan model and the CIS exchange. CIS specification provide an interoperable standardized tool to enable service request and service feedback with DATEX2 payload reference to exchange action proposal and relative answer workflow. And then you also can have a very basic demonstrator of how this is tailored in the DATEX2 Exchange 2020 demonstrator, which allows simply to see how the web service is implemented and allows the message to be shaken. This is a very basic DATEX2 node real-time environment, which allow the exchange and I would say validation of the message. If I break the message, I take some errors here. So I didn't show this in the morning. It shows how any of the interface provided methods can work with within the exchange. So thank you for listening. Hope this has been interesting and complete.